Hi everyone, I'm a student from Beihang University. So today I'm taking a self-introduction. The first question is why this project? So you can see this picture is captured from my ebook shelf. I really like psychology and neuroscience, especially deeply interested in human learning curiosity mechanisms. You see this book, Why Students Like School. This is perfect in psychology. And this one incognito from Eagleman, I think, is really intriguing. And this one surfing uncertainty from Clark. This is a bit hard to read, but it's still fascinating. If you haven't read this yet, I suggest that you could give it a try. It's really interesting. And you can see that this year this is my reading record. I average read 29 minutes every day, and that's been 156 hours this year. So you can see that I really like human curiosity, development patterns, and our intrinsic motivations. This is what I really want to know about. And after we learn this, I want to explore a method to make learning content more engaging and interactive. And so we can apply machine learning to improve our learning experience. So how? So imagine if you think my praise too boring, the content system will automatically skip the boring things. And if it recognizes that some part of this content is a bit more hard, it will provide more detailed information to help you explain, to make it clear. So basically, we are I'm trying to use machine learning to dynamically change based on our knowledge. So the system, first you put some learning content into the system, such as the academic papers, all your textbooks. Mostly they are a little bit boring. And the system will monitor your cognitive load and the degree of interest in real time. And based on these data, it will dynamically adjust content based on your previous knowledge level and your attention. And through this reinforcement loop, we can continuously optimize the content presentation. First, it generates few study chunk to provide to the users, so he can choose which one is the most intriguing one. And while he is reading the more detailed content, the camera is recording his facial expression to figure out the degree of interest, and also the pupil dilation, which is used to analyze his cognitive load, and also the eye tracking, which is the focus of the attention. And these things is provided as a reward function to this content optimization policy. So basically, if the degree of interest is too low, it will punish the policy, telling it not to supply this kind of material next time. And if the cognitive load is pretty high, which means the user is thinking very hard now, it means a good thing at least. So let's learn more detail about the first one, the core part of this system, the content optimization information flow. Basically, the input is about the learning material, the history output sequence, the cognitive state sequence, and the clicking data. and through the embedding layers, it was inputted give it to the pre-trained language model. And the language model will predict the next tokens, which is feed to the curiosity module. The main purpose of this module is to output the expected cognitive state, which means after the user read these tokens, how exciting they will be, and the feedback will give back to the language model. And finally, the text will be output to the screen. And the next question is how to train this policy to make this really work. So just follow like the instruct GPT. We do 3 steps. The first is we use supervised learning to collect human annotated data on content adjustment techniques, such as suspense creation, analog usage, or use narrative packaging. So this phase is basically aims to instruct the model on how to modify content to make it more engaging and appealing to users. And after this phase, we use human-in-loop optimization. So this enables trained network to interact with user continuously and using their cognitive state and click behavior as a reward signal to consequently improve the system. And finally, we want to train a good reward model. This model predicts user states and potential rewards after reading the policy-generated content, and guide this policy to train more faster at least. So the question is, do I have sufficient background knowledge to support my research? And here is a few of my experience. So let me show you. The first one is we use purely intrinsic reward in this is equitable to teach him to be curious about the new state and explore the environment by himself. This is about using reinforcement learning for a one-legged robot to jump. This is by using reinforcement learning to open the door. And this is humanoid arm to pick and place the object. This is about automatic haircut machine. It's pretty fun. And this is also a reinforcement learning environment to put the banana into the refrigerator. And this is about the quad rob dog. And this is the computer vision mission. So you can see that I have equipped it with pretty much, no matter in simulation environment or real world environment, is at least I'm pretty familiar with these things. And that's the self-introduction today. Thanks for watching.